Greetings, I'm Ritika here, and this video is about microbial production of penicillin. Introduction. Alexander Fleming in the year 1928 in September accidentally discovered penicillin. He found that the fungus Penicillium notatum prevented the growth of bacteria Staphylococcus species. Later, Clutterbuck and his colleagues in 1932 studied the nature of penicillins and focused it as an organic acid and that dissolves into the organic solvent at the low pH. Chain and others in the year 1940 cultured fungus and extracted powder form of penicillin. Later, at the time of the Second World War, penicillin production was done and an adequate amount was produced to treat wounded people. Penicillium notatum gave poor results, so other species of penicillin was tested. As compared to Penicillium chrysogenum, NRRL 1951 gave good result which were induced by UV and other mutagenic chemicals. These selected strains produced a huge amount of penicillin and inhibit the growth of the Oxford strain of Staphylococcus aureus. In the year 1945, Fleming, Florey, and Chain shared the Nobel Prize in Physiology or Medicine for the discovery of penicillin. Penicillin variants. There are 6 different penicillin variants are found that are penicillin 1 or penicillin F, penicillin 2 or penicillin G, penicillin 3 or penicillin X, penicillin 4 or penicillin K, dihydro F penicillin, and finally the penicillin 5. Mode of action. Penicillin being beta-lactam antibiotics are specific inhibitors of bacterial cell wall synthesis. They target the synthesis of peptidoglycan by specifically binding to penicillin binding proteins, that is PBP, of bacterial cell wall. This binding inhibits the enzyme activity of this protein. Production strains are stored in a dormant form by any of the following standard culture preservation techniques. A spore suspension may be mixed with a sterile, finely divided inert support. Soil or sand is traditional and desiccated. Spore suspension that can be lyophilized in appropriate media. Spore suspension that can be stored under liquid nitrogen, that is frozen state. Raw materials. First one, the carbon sources. Lactose acts as a very satisfactory carbon compound, provided that is used in concentration of 6%. Others such as glucose or sucrose may also be used. Nitrogen sources, carbon steep liquor. Ammonium sulfate and ammonium acetate can be used as a nitrogen sources. Mineral sources. Element namely potassium, phosphorus, magnesium, sulfur, zinc, and other copper are essential for penicillin production. Some of these are applied by Constip liquor. Calcium that can be added in the form of chalk to counter the natural acidity of CSL. Precursor. Phenyl acetic acid is used as a precursor. Constip liquor. According to Meyer and Gogel, the presence of this material in the fermentation medium gives higher yields of penicillin. Foster and his associates reported that the stimulatory effects of Constip liquor were due in part to arginine, histidine, glutamic acid, and possibly to phenyl acetic acid derivatives. Constip liquor seems to contain sufficient amounts of potassium dihydrogen phosphate and magnesium sulfate. However, small amounts of these salts may be incorporated in the fermentation medium. Inoculum of high-yielding strains of Penicillium chrysogenum. Penicillium chrysogenum NRRL 1951 that was isolated from the moldy fruits was observed to yield much higher yields of penicillin than the Penicillium notatum that was the original isolate. Consequently, the high yield strain was duly subjected to careful treatment with a broad spectrum of time tested mutagenic agents. For example, UV radiation, X rays, and mechloroethamine in nitrogen mustard. Obviously, these mutagenic agents helped a long way in the appropriate selection of several higher yielding nutrients. Several higher yielding mutants. Both Q176 and NRRL 1951 strains gave rise to the formation of a yellow water soluble pigment that is known as a chrysogenin that prominently introduced a distinct yellow tint to the final product of penicillin. Inoculum is first cultured in the flask in wheat bran nutrient solution for 1 week at 24 degrees Celsius. The culture is then transferred to inoculum tanks and grown for 1 to 2 days under aeration. This supports heavy mycelial growth. The inoculum is now added to very large fermenters containing the production medium. Medium that are used in the production of penicillin. Glycerol 7.5 gram, can molasses 7.5 gram, corn steep liquor 2.5 gram, magnesium sulfate heptahydrate 0.050 gram, potassium dihydrogen phosphate 0.060 gram, peptone 5 gram, NaCl 4 gram, Fe tartrate 0.004 gram, copper to sulfate pentahydrate 0.004 gram, agar 2.5 gram, distilled water 1000 ml. Production of penicillin. 100 ml medium with the spores of penicillin chrysogenum strains is inoculated in Erlenmeyer flask and is incubated at BOD incubator by placing them on a rotatory shaker. After 4 days of incubation, the content along with 2 liters of medium is transferred into a flask that contains 4 liters and again incubates for 2 days. Then the content is transferred into a stainless tank containing 500 ml of the medium that provides a suitable condition for fungal growth. After 3 days of incubation, the content is used for the inoculation and kept in a fermenter that is well equipped with optimum conditions. The content is filtered after 6 days of incubation, which contains penicillin. The penicillin is extracted into amyl or butyl acetate and is transferred into an aqueous solution with phosphate buffer. Acidify the extract and again re-extract penicillin into butyl acetate. In the solvent extract, potassium acetate is added to the crystallization tank to crystallize as a potassium salt. Crystals were recovered and further sterilization of salt is done. Downstream process. Once the entire fermentative procedure is accomplished, is that at harvest, the completed penicillin fermentation culture is subjected to filtration by the help of heavy duty rotary vacuum filter to get rid of the penicillin pulse, other unwanted solid residues. The pH of the clear filtered fermented broth is carefully brought down between 2 to 2.5 by the addition of a calculated amount of either phosphoric acid or sulfuric acid so as to convert the resulting penicillin to its anionic form. The resulting fermented broth that the pH that is ranges to 2 to 2.5 that is extracted immediately by using a pod bell-like countercurrent solvent extractor. With an appropriate organic solvent, example amyl acetate, butyl acetate, or methyl isobutyl ketone. Penicillin, thus obtained, is back extracted into aqueous medium from the corresponding organic solvent by the careful addition of requisite quantum of KOH or NaOH to give rise to the formation of the corresponding potassium or sodium salt of the penicillin. The resulting aqueous solution containing the respective salt of penicillin is again acidified and re-extracted with the organic solvent methyl isobutyl ketone. In fact, this shifts taking place between aqueous and solvent medium help in the ultimate process of purification of the penicillin. The resulting solvent extract The resulting solvent extract is finally subjected to a meticulous back extraction with a aqueous NaOH preferably a number of times till extraction of penicillin is to crystallize out either as a sodium or potassium penicillin. The crystalline penicillin thus obtained is washed, dried under vacuum, and final product must match with the specifications laid down by various official compendia. Thank you.